In the previous video, we have been discussing about how to create a standing wave by having interference of two progressive waves traveling in opposite direction. So we learned that if we send a wave in one direction and let the wave reflect and get back to us in the opposite direction, that two waves will interfere, and the result of the interference is a standing wave, as you can see here. So we know that the equation for a progressive wave is y equals to a sine omega t plus minus kx. But how about the equation for standing wave? What is y equals to for a standing wave? And that is our aim for this video, to determine the displacement equation for a standing wave. So a standing wave, it's formed due to the interference of two identical progressive waves traveling in opposite direction. So one wave traveling to the right will be a sine omega t minus kx, and this wave will overlap with the reflected wave that is formed by this equation, a sine omega t plus kx. Negative kx is the wave that is traveling towards the positive direction. Positive kx is the wave that is traveling towards the negative direction. So these two waves are traveling on the same medium, so definitely they will overlap at the same region. So when they overlap, interference occur. So how do we obtain the equation for the standing wave? Well, we have to use something called the principle of superposition of wave. So principle of superposition of wave tells that if you have two waves and they are moving in the same region, right, the resultant wave or the resultant displacement at any point is the vector sum of their individual displacement at that point. It might sound like a very difficult sentence, but what they are trying to say is the resultant displacement at any point means, like, let's say we are interested to find the y at x equals to 3. Okay, so how do we know what is the y at x equals to 3 when these two waves overlap? What we do is we substitute x equals to 3 inside here. We substitute x equals to 3 inside here. Then we will know the y at x equals to 3, right? So if we add up the y for the first wave, we add up with the y of the second wave, then we are doing a vector sum of the individual displacement. This is individual displacement 1, this is individual displacement 2. If we perform a vector sum, if we add them up together, then that will be the resultant displacement, and that will be the displacement that you see on the wave at x equals to 3. Okay, to keep it simple, it just tells you that if you take y1 and you plus y2, you get the resultant displacement y. And the resultant displacement y here will be an equation, and that equation here will be the displacement equation for standing wave. So if you add this equation with this equation, you get the equation for standing wave. Okay, so basically what does it mean is we are using this principle of superposition of wave to explain why we see this kind of stationary wave when two waves interfere. We know two waves definitely overlap, but how do they overlap? You need to explain it using principle of superposition of wave. Principle of superposition of wave tells you that when two waves overlap, you add them up. You don't multiply, you don't divide. Superposition tells you that you add them up. That's the main point for superposition of wave. So now let's try to progress through the equation, the derivation, to obtain the equation for standing wave. We know that y1 is a sine omega t minus kx. This is the wave that is traveling in the positive direction. We know y2 is a sine omega t plus kx. This is the wave that is traveling in the negative direction. We know that these two waves here have the same amplitude, same angular frequency, and same wave number. So what we do now is we factorize out the amplitude. So you get a statement like this. A is outside, the amplitude is outside. Inside the bracket, you have your first term sine omega t minus kx, and the second term sine omega t plus kx. So what we are going to do now is we are going to use a trigonometric identity called the double angle trigonometric identity. So this trigo identity tells us that if you have sine a plus alpha plus beta, what you can do is you can break it open to become sine alpha cos beta plus cos alpha sine beta. That is if your bracket inside here has alpha plus beta. But if it's alpha minus beta, then it will be sine alpha cos beta minus cos alpha sine beta. What happened here is you write sine cos first, then you invert order, become cos sine. but order is always alpha, beta, alpha, beta. So you follow the sign. If this is plus, then this is plus. If this is minus, then this is minus. So this is double angle. So let's try to apply it here. You can try to check it yourself whether it's correct or not. But yeah, this is the result of you using the double angle trigo identity. So now when you have used this trigo identity already, I believe you can notice that sine omega t cos kx, it's the same as this sine omega t cos kx here. And you have a plus sign in front of it. So these two will add up to become 2 sine omega t cos kx. Okay, but you look at this second and the fourth term over here. The second term is negative cos omega t sine kx, whereas the fourth term is plus cos omega t sine kx. So it's a negative sign and a positive sign here. So if you add these two things up, it will be equal to 0, because one is negative sign, one is positive sign. So these two terms will cancel out. So what you are left with is just 2 sine omega t cos kx. Okay, this one add up with this one, you get 2 sine omega t cos kx. If you bring out the 2 to the outside, then you get 2a sine omega t cos kx. Well, this is the equation for standing wave. It's just that easy. You just need to use the double angle trigo identity, then you can obtain the equation for standing wave. But this equation here, we don't usually arrange it that way. What we usually do is we express it in this form. How is it different? We bring the cos kx to the front, we bring the sine omega t to the back. We usually express kx front first, omega t behind. Why is it so? I will explain it in the video when I talk about the properties of standing wave. So 2a here tells you that it's no longer the same as a progressive wave. Okay, 2a here, we can change it to become a symbol called a subscript SW. So it means amplitude subscript standing wave. So when you see, if you see equation use a cos kx sine omega t, right, you know that the a is a different a from the a of the progressive wave. This a, this amplitude is the amplitude for standing wave, but it's not exactly just amplitude, it's a maximum amplitude for standing wave. We discuss that later as well. Okay, so if you see an a in front here, make sure you are aware that this a is different from the a in the progressive wave. In fact, the a for this standing wave here is twice the value of the a for progressive wave. Okay, so take note of that. This a is different from this a, and this a for standing wave is actually twice the a for progressive wave. So this is the equation for a standing wave.